World Health Organization statistics reported that globally more than 80% of the wastewater produced by the people and their economic activities flows back into the ecosystem without being treated or reused.
This puts around 1.8 billion people at risk contracting diseases such as cholera, typhoid, dysentery, and polio.
Around 842,000 deaths each year are caused by unsafe water, poor sanitation, and hygiene.
According to Water.org, out of 101 million Filipino people, 9 million rely on unimproved, unsafe, and unsustainable water sources, and 19 million lack access on improved sanitation.
Many of the people who inhabit these rural areas have little to no income, thus making it difficult for them to afford clean drinking water. Data from UNICEF shows that only 82% of the people who live in these rural areas have access to potable water.
Much of the water available is obtained from streams or springs that are contaminated with runoff from farms or the careless dumping of garbage by individuals.
With little spendable income for most, it becomes impossible to properly filter the water that causes 4% of death and 5.7% of ill health.
The contamination of water starts with water being contaminated with bacteria due to improper storage and preservation, an act that leads to various diseases and worse, citywide dengue outbreaks.
People that live in slum areas must also be educated about proper sanitation. This is one of the community problems that led to water contamination. They may also lack water for basic hygiene to wash themselves and their clothes, and to prevent infection including from foodborne and waterborne diseases.
The major sources of water pollution in the country are inadequately treated domestic wastewater or sewage, agricultural wastewater, industrial wastewater, and non-point sources such as rain and groundwater runoff from solid waste or garbage deposits, which is also known as leachate.
Around 1 in 10 people still do not have improved water sources. Inadequate and intermittent or water supplies around Metro Manila and other parts of the country still have serious health consequences.
According to a book entitled The Quest for Pure Water, The History of Water Purification from the Earliest Records to the 20th Century, the pursuit for pure drinking water began during the prehistoric times.
However, authors M. Baker and Michael Taras stated that the earliest documentation of water treatment dated back to 2000 BC, when it was still written in Sanskrit inside Egyptian tombs. Old water treatment methods include boiling of water over fire, heating of water under the sun, dipping of heated iron into water, and filtration through gravel and sand.
During the 17th century, Sir Francis Bacon, an English statesman and philosopher, referred to desalination as an alternative form of water treatment, wherein the salinity level of seawater is reduced to the point it becomes potable. Additionally, an Italian physician named Lucas Antonius Porcius expounded the method of multiple sand filtration in his writings. Eventually, the water purification method of filtration was integrated into many communities up until the 18th century.
Furthering down the timeline, the importance of water quality was beginning to get recognized during the 19th century. From then on, people focused on developing new water treatment systems that are more advanced in nature without risking the quality and safety of drinking water. In the Philippine context, water purification began through water treatment plants like the National Water Works and Sewage Authority or NOWASA. According to an article at the official government website of Virac Water District, water purification in the country undergoes a process of physical means like sedimentation and filtration, biological means like rapid sand filtration and flocculation, and chemical means like disinfection by chlorination.
However, during the rise of the popularity of bottled water in the 1990s, water had also undergone several other water treatment processes that appealed to more consumers in the public market.
The marketability of distilled drinking water was unlike any other. Thus, distillation became a well-known water purification method in the country.
According to an article at Water Filter magazine, the distilling process is done through boiling, and then, after steam and condensation, it returns to liquid form but also leaves behind chemicals, minerals, and any other particles that were in the original water. Therefore, distillation kills microorganisms such as bacteria and some viruses, and effectively removes inorganic compounds such as metals, nitrate, and other nuisance particles. This is the reason why some people find distilled water tasting flat.
Despite the taste, the benefits of drinking distilled water are worth noting. Dr. Edward Group, founder of Global Healing Center, enumerated the said benefits of drinking distilled water in a self-written article at their official website.
First and foremost, distillation removes waterborne contaminants and alleviates the risk of future illnesses. Second, chemicals that can be harmful to the body when ingested in undiluted amounts are removed. Thus, distilled water is also referred to as the true pure water. And lastly, distilled water has no additives unlike tap water supplies that may contain calcium, wherein too much of its consumption may result in kidney stones.
As time passes by and technology advances, people continue to research on and innovate new sophisticated distillation processes. Since removing impurities is the main priority, there are different ways in doing so.
One is by using heat, also known as vapor compression. Water undergoes a boiling process that converts it to steam. The steam is then pressurized, which raises its temperature, and in turn, the pressurized steam transfers its heat to the new water inside the boiling chamber and creates more steam. As the pressurized steam gives off its latent heat, the steam inside the chamber condenses. The condensed steam is considered the distilled water, as the impurities from the beginning were removed during the distillation process.
Another is by using multiple boilers in distilling, also called the multiple effects. It follows a similar process to vapor compression. However, the multiple effect system uses from 2 to 6 boiling chambers, making it a more efficient version of vapor compression.
Lastly, is by using activated carbon. Carbon has a larger surface area that is beneficial when it comes to taking all of the impurities. And using carbon mediums can be a better substitute to boiling water since they have a higher boiling point, thus creating a more concentrated steam that is left to be distilled.
Utilizing activated carbon has been widely recognized as a water purifying agent. Researchers have used it in their studies, both local and abroad, which is why it is also our report's main focus, along with another potential water purifying agent, Moringa oleifera.
So Jai, how did you come up with your thesis and what inspires you to do that?
So, we firstly used the banana peel and the apple peel, which could allegedly attract heavy metals, which are also impurities in the water, but it didn't work. We secondly used the present coagulation properties of the cactus, but since it is not locally available, we didn't make use of it. So we found researches and we actually found that Moringa oleifera has a cationic property which could actually attract negative impurities in the water, which could actually result to a process we call coagulation, which could potentially clean impurities in the water.
So what inspired you to do a study about water purification?
So we firstly gathered information through the local government of Carmona, Cavite, particularly the Municipal Environmental National Resources Office or MENRO in our municipality, and we found out that there are actually a lot of water resources, particularly groundwater resources in our community, but the thing is this can't be utilized as this can't be consumed by human, or this was not potable water. So this was classified as pea water. So what we wanted to do is actually made a cheap device that could actually be used by the communities who live near it and use it to have potable water accessible to their homes.
Can you tell us the materials
The materials used in the study was actually all recyclable materials. One of them was the two water containers which can be found in every household, and valves plus pipes. For the main water purification process, we use the locally found Moringa oleifera, or also known as the malunggay, and we also use some commercially activated carbon which can be bought in the near supermarkets here in the Philippines.
How did you come up with the decision of using those materials?
Firstly, we were tasked to actually find materials which was commonly found in our municipality. One of them was the Moringa oleifera, and we found out that this Moringa oleifera actually has some cationic properties which attracts impurities. The second one was the prominently used for water filtration, which is the activated carbon, which was already available in our municipality also.
Can you tell us the step-by-step process of making the device?
So in making the device, we made it so that it could be a two-stage water purification. For the first stage, we would use the Moringa oleifera, which would be dispersed into the water. So we use the water containers. For the second stage, we use another water container, and we put a little container inside the biggest container so that it could serve as the filtration for the first stage. And to connect the two containers, we use valves and pipes.
What are the tests that you use in the device to determine that the device that you created works?
So we use the parameters by the Department of the Science and Technology, and also the parameters used by the World Health Organization. These parameters determine that the water could be potable or could be consumed by the humans. So the first one is the pH level, conductivity, turbidity, dissolved oxygen, ammonium content, iron content, biochemical, and lastly the biochemical and oxygen demand, or also known as the BOD.
Can you identify the likely problems in this process?
The likely problems in this process is that the chemical reaction between the coagulant and the water, the coagulant being the Moringa oleifera and the water being the contaminated water found in their locality, the chemical reaction between these two is actually really slow, so it would take a lot of time. And when you wanted to purify in 1 liter of water, it would take you almost an hour.
Why is your area of scientific discovery relevant for the ordinary citizen of this country?
Before actually conducting this study, the mayor of our municipality actually urged us to make a research or an innovation which would actually help those who does not have a stable social economic status in our community. So what we first found out that there are actually some places in our locality which still does not have access to potable water. So we chose this area of scientific study.
Are there any problems that you have encountered and solved during your most recent project?
The problem we encountered was that we needed to make a device that does not actually consume any financial difficulties, because we wanted to make a device which could be cheap and available to those who actually needed it. Second is that we needed a device that does not consume electricity. So through the use of gravity, we used so that the device could actually transfer water from one stage to another.
What happens next in the process of discovery?
What happens next is actually the communication part of the research, wherein the results of the research should be presented to those who actually need it. So we presented the research to our mayor, who applauded it, and we actually introduced it to those who actually needed it, particularly on those areas where there are really no available potable water.
If the device will be integrated to a small local community, what difference will it give to the community?
First, when it was introduced, many people actually didn't accept it since it really take up too much time to be able to purify a small amount of water. But then this serves as a great way and another cheap way to actually bring them potable and safe water which they could actually consume and drink, other than the water that they could get from the dog well, or what we call poso.